In this problem, two blocks of masses m1 and m2 are connected through spring of spring constant K and is kept on frictionless surface. Both the blocks are pulled with forces F1 and F2 respectively. We are required to find out maximum elongation in the spring during subsequent motion. Fine. Now let's solve this problem using one of the methods, that is center of mass frame. Actually, there are many more methods to solve this problem. We'll be using this center of mass concept. So if we sit in the center of mass frame here and we observe the motion of the blocks. So in this frame, actually the center of mass frame is itself accelerated, whose acceleration is equal to F2 minus F1, that is the net force over total mass m1 plus m2. So this is an accelerated frame. So if we are sitting here and observing the displacement of the block from this frame to be, let's say, x1 and x2 be the displacement at any instant of time, then we will be applying work energy theorem from this frame of reference, that is work done by F1 plus work done by F2 plus work done by spring force, and also the pseudo force will be there since this is an accelerated frame and whose acceleration is AC towards right. So here a pseudo force of m1 AC and here also a pseudo force of m2 AC will be there, right? So work done by spring plus work done by pseudo on the first block plus work done by pseudo on the second block, and that is equal to change in kinetic energy with respect to the center of mass. Okay, fine. So we have work done by F1 as F1 times x1 because force and displacement both are in the same direction plus F2 times x2. This is the work from center of mass frame, and work done by spring force will be negative of half k x1 plus x2 whole square. It will be same as from the ground frame. Okay, and now about this pseudo force work, that will be plus m1 AC times x1, and for pseudo force 2, that is plus m2 AC, and displacement and x2 both are in opposite direction, so I am putting here minus x2, and that is equal to delta k cm, that is half mu relative v relative square. We know how to write kinetic energy from center of mass frame, that is half mu v relative square minus initially 0. Also we can see that during the maximum elongation, relative velocity of one block with respect to another will be 0. So this term is also going to be 0, and we are required to find x value of x1 plus x2. Let's say x1 plus x2 is x, and also since we are observing this from center of mass frame, m1 x1 minus m2 x2 must be equal to 0 because coordinate itself is located at center of mass. So we have m1 x1 is equal to m2 x2, and from here, from 1 and 2, we can say that x1 over m2 is equal to x2 over m1 is equal to, I'm applying Componendo Dividendo, so it becomes x1 plus x2 over m1 plus m2. And by the way, x1 plus x2 is x, so we have x1 as m2 over m1 plus m2 times x, and similarly x2 as m1 over m1 plus m2 times x. Now look at this equation, work energy equation. Here I'm writing here f1 times x1. The value of x1 is f1 times, I'm putting this value, that is m2 over m1 plus m2 times x plus f2 times x2 is again m1 over m1 plus m2 times x. Now, what is this value? If you take AC common, it becomes AC times m1 x1 minus m2 x2, and this value, we have this work done by the spring force as minus half kx square, x1 plus x2 as x, and this value is equal to 0. You can also see that m1 x1 is equal to m2 x2, so this value is again 0. So net work done by pseudo force will be 0. So further we have f1 m2 plus f2 m1 over m1 plus m2 times x, and this is equal to half kx square, and from here we can find the value of x. I'm writing here that x is equal to 2 over k times f1 m2 plus f2 m1 over m1 plus m2, and that's it. I hope you understand it. If you have any question, do comment below, and if you like the video, do subscribe and like and share. Thank you very much.